Hi, this video is on how to set up external static pressure for LG ducted units. This process is not straightforward, please pay attention. I separated this video in two parts. First part is what you must know to set up static pressure, and second part is about theory and background. Let's go.
There are two types of IDU units, ducted and ductless. ESP or external static pressure we can set only on ducted type IDU units. To set up static pressure properly, we need to know three things: model of the IDU unit, static pressure, and airflow. This comes from the designer of the ductwork. In this video, as an example, I will show you how to set up static pressure on 6-ton ducted type IDU unit. Let's say we've got this information from engineer, or we designed ductwork ourselves, and for our ductwork we need 0.7 inches of water gauge static pressure and 2000 CFM of airflow. In this video we will stick to imperial system of measurement. If you need the metric system, please contact your local LG representatives or convert yourself. Okay, now we have all we need. We have model name, airflow, static pressure, and we're ready to set up ESP. We need to find manual for this unit. It can be in a box with this unit, or if not, we can download it online.
Finding the manual is very easy. You just go to official website, put the model name in the search. You can do it from your cell phone as well. Searching, here is our unit. Here is a list of manuals related to this unit. We need engineering manual. Download it.
In the engineering manual, let's stop a little bit on how to read model of the unit. In some cases we need to know capacity of the unit to set up ESP. As you can see, it's a first number. And after electrical ratings, the next two symbols, here it shows as the model, and also it means the type of the unit or type of the body of the unit and type of the chassis of the unit. In our case here it's B8 type of the unit. Scroll down and find external static pressure and airflow tables. As you can see on this page, we have three tables for units types BH, BR and B8. It means that all units in this type family, they have same fan motors and same static pressure and airflow settings. Now let's look at our B8 table. Let me explain how it works. Based on our example, we need to set up 0.7 inches of water gauge static pressure. Let's look, the closest column is 0.71 inches of water gauge. Good. Now let's go down and find the closest value to our 2000 CFM. It will be somewhere here, in between these two values. Extend it to the left, and our set value will be somewhere in between 91 and 95. For 2000 CFM, I think true will be something around 92. Now is the most interesting part, setting of ESP.
In old thermostats it's a function 3. New thermostats they just labeled ESP, which is easier. This function has 5 ESP steps, we'll talk about it later, and actual ESP set value. ESP settings has values from 0 to 255. LG have different types of thermostats. They all compatible between ducted and ductless units, between commercial and residential. And they all have option to set up ESP in a range from 0 to 255. Back to our example, B8 family units have a set value range from 60 to 105. From factory, all thermostats by default set on 0. Same as ducted type Indo units. When they come from factory, they all set for maximum ESP. Let's say if we set value on 60, it will be lowest possible ESP setting for B8 type unit. When we set value on 105, it means that this is the highest possible ESP setting for B8 type unit. Let's say we set value 106. It is still maximum possible ESP setting for B8 type of the unit. No difference from setting value of 105. Same would be all other setting values up to 255. If the value set 59, it's still the maximum ESP setting for this unit. And it will be highest ESP for all values set from 0 to 59. So, adjustable range for B8 type Indo unit is only from 60 to 105, and this range is different for different types of Indo units. Here, next few slides I collected and put together all ESP settings values for all types of Indo units available at the moment of recording this video.
Now let's talk about ESP step. ESP step has 5 levels, each level representing fan speed, which will be selected by user during the operation. Ducted type Indo units have 5 fan speeds, when ducted type Indo units have only 3 speeds, low, medium and high. And this causing a lot of confusion for technicians on site. Again, for ductless units we have 5 speeds of fan, when the ducted types of the Indo units have only 3 speeds, high, medium and low. Let's go back to our example. As we discussed, we need to set up set value 92. Go to ESP. Here you have selection of 5 speeds: high, power, high, medium, low and slow. So for ducted unit we need to set up low, medium and high. Let's say we'll go to high, and we have range from 1 to 255. Okay, if we need to set up, which you can just hold and go to setup 92. Press OK. Change has been completed. We just set ESP settings for high speed of fan value. It means when user select high speed of fan on thermostat,
the fan in the unit will provide 0.7 inches of water gauge and 2000 CFM airflow with the current selected ductwork.
Then we can select the same set value for medium speed and low speed of fan. Now, whichever fan speed user select, it always will give the same airflow and static pressure. Depend on the ductwork, depend on the job application, we can set values for low and medium speed lower. It should be lower than selected setting for specifically this ductwork, and in the range of the setting value for our Indo unit. In our example, 60 is the minimum setting, so let's say we set 60 on the low speed and medium something in between, let's say 75. Again, double check with engineer and make sure that user knows that airflow will be lower with low and medium speed of fan. If you set anything in the levels of slow or power, nothing would happen. These settings just ignored on the ducted type INDU units, same as if you set any external static pressure settings on ductless INDU units, same, it will not respond. Few words about group control. You cannot set up ESP for all units in a group from one thermostat at the same time, even if all units are the same in a group. You need to set ESP on all units in a group one by one. Get one thermostat, plug it into CN Remo plug on the INDU unit PCB, set up ESP, then reconnect to another unit and do the same. You need to do it once during the installation and setup process. Here is step-by-step detail on how to do that. Make sure you kill the power, connect one thermostat to one INDU unit, then apply power on the INDU unit, wait about a minute for initialization, set up your ESP settings, kill the power, disconnect thermostat, then reconnect all group wiring back and apply power on INDU units. Done! Now let me show you some examples on how do I setting up static pressure on different types of thermostats.
You go to installer setting, fan settings, scroll to the ESP settings, and again we have 5 speeds. For the ducted unit, it works only low, medium and high. Power and slow doesn't work for duct unit. Let's say we go to high, and we have a range of 255 here. Okay, you can go back. So you will select 92. Okay, you can go up. Installer settings. ESP. Oops. So now here, wait. ESP, we have 5 speeds: slow, low, medium, high and power. Let's say we select high. Here's easier, you just type 92, enter, and it's set. High is set for 92. Same you do with me. Function 3, select speed 4 and set up .92. Okay, escape. Choose it on high and select 92. Okay.
If you watch video up to this moment, let me show you another way how to find out ESP setting value. This is the LUTs program. This is a free software for LG multi-V systems design. Let's go. Same conditions. 6-ton high static ducted type INDU unit, and we need to set up 0.7 inch of water gauge static pressure and 2000 CFM airflow. Double click on our unit, go into the properties of the unit, selecting our 76,000 BTU in the unit. Here we have default values for this unit, again for high, medium and low fan speed. We are interested here for manual setup. 2000 CFM for airflow, and 0.7 inch of water gauge for static pressure. And it shows setting value 94, which is pretty close for what we selected from table. If everything designed properly, this information will be in LUT's report. Let's talk a little bit about theory behind it. Let's say this is our fan in our Indo unit. Each fan has two main characteristics. It is static pressure and airflow. Let's start with airflow. Airflow is the measurement of the air which is entering and exits our air conditioning system, in our case Indo unit. Here on the slide is example of cubic feet of regular air, and our fan is just pushing these cubic feet of air one by one. Let's say we measure how many cubic feet of air can be transferred by this fan over the minute, and we're getting measuring unit cubic feet per minute, or how it's called CFM. That's all we need to know about airflow for now. Let's talk about static pressure. The static pressure is a resistance to airflow, or in other words, how fan can fight this resistance. Let's check an example. We have fan A and fan B. Fan A is able to push air like this, and fan B is pushing air like this. By this animation, we can see that fan A is able to push air against higher static pressure rather than fan B. Static pressure is measured in inches of water gauge. There are other units exist to measure airflow and pressure. In this video, we will stick to imperial system. Please convert if you need metric system. This is a device to measure static pressure. Let's put the values on the chart now. On the vertical axis, we'll put static pressure. On the horizontal will be airflow. Each fan has a value of airflow without resistance. It's also called free delivery. Also, each fan has a static pressure without airflow value. Let's say if we close fan discharge and measure the pressure. Let's say it will be this value. In between these two values will be chart like that, which is called fan curve. Okay, this is clear. Let's talk about ductwork now. Again, let's say we have two cases, A and B. These two fans in two cases are representing the fan in LG Indo unit. It is ducted type Indo unit, and it is expected that it will be connected to ductwork. Let's say we connect same Indo unit into two different ductworks, ductwork A and ductwork B. Ductwork B is a little bit longer than ductwork A. Ductwork A has less volume inside the duct in comparison with ductwork B. The fan needs to create less static pressure to push this air through the ductwork A rather than push it through ductwork B. Let's illustrate it through the chart again. Low static ductwork A would look like this on chart, and ductwork B would create higher static pressure for fan, and on the chart it would look like this. Let's put our fan curve back. Now, with this simple example, let's see why it is so important to select the fan properly and set the static pressure properly. In this particular case, for the ductwork A, small changes in airflow will cause significant changes in static pressure. This particular fan set to this fan curve will not run stable with ductwork A. Before we go to ductwork B, let's check another example with ductwork C. This ductwork have a high static pressure. The graph to this ductwork would look like this. In this example, it goes on the top of our fan curve. In this case, small changes in static pressure will cause high changes in airflow. Again, our fan will not run stable. Now, let's go back to our B case. With ductwork B and current settings for the fan, small changes in static pressure will not cause significant changes in airflow, and vice versa. This intersection of the fan curve and system chart is also called operation point. In our example, ductwork A and ductwork C operation points are located in the area of instability, when ductwork B is in kind of a safe operation zone. When engineers designing a ductwork, they taken into account duct size, number of turns, and a lot of other variables and constants. That is why it is very important to know airflow, static pressure before we start setting ESP. Let's summarize what we just talked about. First of all, proper INDU unit need to be selected to cover required loads, airflow, and static pressure. Each ducted type INDU unit has a range for setting airflow and static pressure. From factory, it comes with ESP set to high. Let's say if ESP is not set for the designed ductwork values. So our unit is set to high static pressure from factory, and from here we have three possible scenarios. Let's say we're lucky and we got into a stable operation point. Another two, if we are in area of instability. It even might not be noticed by user, however, it will constantly give change in loads on the fan shaft and bearings, which eventually will kill the fan motor, and fan motor will need to be replaced.